In this video, I want to cover a topic that I recently got really excited about, and that is creating your own shaders using Cursor AI. And I have a different video where I covered how to create GLSL shaders for Touch Designer. And in this one, I want to focus on how to create them for Resolume Wire and therefore also in Resolume. And that's just a really cool way of creating your own sources and generative effects. Just an example here in Wire that I have open right now is this tunnel, this cubes tunnel that I was messing around with. And that is basically this kind of grid of cubes that I can fly through. And I can create this kind of wave animation. I have a randomness for the position. I can change the size of my cubes. And then I can also change the speed. And I mean, this is just like endless possibilities that you can create with a generative effect. And that was created in Cursor AI using Claude as a AI agent. I also have this other example here of this 3D fractal, so you can really go crazy and also create some very complex kind of 3D scenes that are all rendered in real time in here. And yeah, this is just, I mean, this is honestly just crazy. When I figured this out, that this is possible and how good Claude is by now at coding this, I was just blown away. Let's jump right in and cover some of the steps on how to create this. Now, just some fundamentals here. We are writing GLSL shaders. GLSL shaders basically, in essence, are programs that are running on the GPU, which is why they are so incredibly efficient. There is a great resource on the fundamentals of shaders called the Book of Shaders, which I highly recommend, and I will link it in the description. And here, like the whole process and the whole concept is explained in great detail with some great visualizations. And it's also just in general, if you're in this kind of art form, it's just very interesting to think about anything visual created, you know, by code, which is what's happening anyway behind the scenes, right? So yeah, that's just a very interesting and great resource on the basics of shaders. And I highly encourage you to learn the fundamentals of shaders because even though we can use AI to help us code them, it will still be very, very helpful to understand what is actually going on. And that way we can troubleshoot easier and we can also change stuff easier. And that's the most fun way to explore this is to do it kind of in a collaborative way. And that way you can also start messing around with the code yourself and figuring out some completely new things that you wouldn't have otherwise. Now, what we are going to use are so-called ISF shaders, and ISF is basically just a wrapper for GLSL shaders that allows you to have some of the metadata in an extra header just to be able to have this exact effect that well, not effect, but the function here that you have these sliders already kind of predefined with your values that you want to export and all of that stuff. So that's like one of the main things that that this ISF is doing, the ISF format is doing, and it's just this kind of standard that is accepted by many different programs and VJ software explicitly as mentioned here. So you can even go to this page, where is it? Integrations. So here you can see all of the programs that support ISF shaders, and those are quite a lot, and some, you know, very similar, very familiar programs right here. So Touch Designer, Resolume, Mapper, they all support synesthesia. They all support these ISF shaders. And you can also go to this ISF sharing site. And right here we have a page where you can browse some different shaders that are that people put online here. And in fact, let's just try messing around here with this one. And this is the cool thing about shaders, is that they're very interoperable. So they not only work in these programs, but they even work in the browser. And so that way we can actually view those shaders in real time and change some stuff here. So, it's a huge topic. I definitely recommend getting into it and checking it out. Very interesting stuff. But for me, it was always kind of daunting to just get into this whole coding. I just very visual person, and to me, it's way easier to work in a node-based environment. But this kind of approach using AI really helped me to get into it, but also helped me understanding the code more. And it took away some of this fear of writing code, because it's a very iterative process with AI. As I mentioned before, the software that we are going to need and going to use for this is Cursor. So you will need to download this. And once you log in, it will look something like this. One of the cool things about Cursor is that you can set a predefined context for your scripts. Now, some of the basic shortcuts here are Command B or Control B on Windows to open up your palette here on the left. What's it called? The primary sidebar. And here you can define a project file. I already have it open right here, but you can just say File Open or Command O, and then open up a new workspace, which is going to be just the folder where you're going to work in general. I'm going to have my folder on my desktop created here, and I'm going to select that one. And that's going to be the folder where I'm going to work in. And if you press Command I, you will open the agent or the AI panel on the right. And you can see that we are using Claude. It's selected 3.5 right now. I'm going to go to 3.7. That's the latest version. Now the agent here, you can also switch to ask mode. You can also do that by Command L. So Command I for agent and L for the ask mode. And the difference is that the agent will act right away and change your code, write some stuff, create files. And the ask mode is more for asking about the code itself, what is going on, or stuff like that without any direct actions. You can also input images. So here you can, set some like reference images or stuff like that and say, something like, try recreating this scene with a shader or something. So that's also kind of cool. The powerful tool in Cursor is that you can set a predefined context for everything that you do in a project. That means that you can create a set of rules that will always apply to anything that you create inside a project. And this helps you to, get consistent results. And, while being in this iterative process with you and the AI, you can learn from that, see what kind of mistakes the AI is doing, repeatedly, and then just, tell it not to do them again. So if we open the settings here and we go to the rules tab, here you can create new project rules. So you have to have a project defined for this. So that's why we opened this folder before. Otherwise, this won't be possible. And I already have created this rules ISF Shaders wire. So if you add a new rule, you can name it. I'm going to open them right here. And what you can do here is, first of all, you can either input links. So I actually just put in the reference to the ISF shaders here. So just to the docs. And it can use that as a reference for coding its shaders. And then you can also input just some bare text, like text prompts. So I didn't need to use any for ISF for now. This was more important on the Touch Designer workflow. But sometimes, it just makes the same mistakes all over again. And then here you could say something like, never do this, never do that. So that's just a very handy tool that will allow you to eliminate a lot of mistakes and errors. Also, one thing that's important when you install Cursor for the first time and you want to edit GLSL code, you want to head to the extensions here and then search for the GLSL literal extension. And that way you will get the syntax highlighting for GLSL code. So, you know, all the color coding, which makes it way more readable. And that's just something you want to install as well. Okay, let's try creating our first shader. And what I want to do is create an effect for Resolume to have a sort of chromatic aberration effect. And I'm just going to tell it to create an ISF shader for a chromatic lens aberration of an input image. And there we go, it created our code, and in fact it created a new file in our directory, so chromaticaberration.fs. We can accept the file with Command Enter and save it. And here you can already see the variables that are kind of exported as our values that we can change. So we have the input image, the aberration amount, radial factor, red, green, and blue offset. So let's try opening that inside of Wire. I'm going to create a new file. I'm going to open up my folder, look for the file, and just drag it in here. And then I will need some kind of input. So I'm just going to use I'm just going to use the texture in, because that's what we will need to feed our video inside of Resolume, so we can use it as an effect. And we can drag that into the input image. And now if I select my chromatic aberration, we can see that it's already being applied and it's already working. So that's looking good. Let's open that up and select our node here. Let's start messing around with some of these values right here. So yeah, that is already doing what chromatic aberration does. We just have a lens like left to right, but that's all right. Okay, in fact, it does let us change to a radial factor. Okay, there's some interesting stuff going on here. Again, this oftentimes this will create some, very weird results that you maybe wouldn't be doing in this way. But that's also kind of what I find very interesting in the whole process. So, it's probably better at doing stuff weirdly than doing exactly what you want it to do. But if you are open for the experiment and the happy accidents, then this is something really exciting. And so, just for the sake of demonstration, I'm not going to bother too much about how all of this works right now, but just demonstrate on how we can actually import this into Resolume Arena. So to actually be able to see this in Resolume, we also need a texture out. So we're going to say texture out here. And one more thing is that we need to go to our patch settings. And in the category, we're gonna tell it this should be an effect. And I'm gonna call it aberration tutorial. Now, the other thing that we want is we want to be able to control these parameters from inside Resolume. And we need inputs for that. Now, the easiest way to create that is just right click on the node and tell it to expose the inputs. And that way we get our time, our aberration amount, and the radial factor. This time variable is oftentimes used to animate some values, but in this case we don't really need to animate anything, so it doesn't make too much sense. We're just going to skip that. So we only need the aberration amount for now and the radial factor. And then we can save it. We can go into Resolume. We can look for a new source, for instance, the Linescape. So let's open that. I'm just going to make it a bit slower. And then if we look in the effects for the for the aberration tutorial actually, then you can see that this is our effect. And here is our effect with the exported values. So You have the radial factor, you have the aberration amount, and this is actually looking really cool. So now I also tried to add this to metaballs, and especially when you have input that is very smooth, you get this really beautiful, aberration effect that is just, very nice. So that's basically it, and you can already see how powerful this is and all the possibilities that you can create with this. So either, you can create effects, video effects, that you use for your sources inside of Resolume, or you can create your complete custom shaders like generative sources as this as these fractals or these tunnels that I showed you before. But let's try to create some kind of like cube cloner animation. So I'm just gonna create a new window here. I'm gonna take out the context of this code and maybe just close it, and then try to create a kind of looping animation of array of wireframe cubes, and I'd like to animate parameters like speed, random, size, rotation, line thickness. Let's go for it and see where it takes us. All right, cool. So quite a lot going on here. Let's save this and open it up in Wire. I'm just gonna create a new file, import the cubes, and there we go. We actually have an error message. And so when you get a message like this, one thing you can do is, of course, troubleshoot by hand. It seems that maybe it's defining the variables with different names. But what you can always do is just copy the message here and then just paste it into the agent. And usually this doesn't work too bad in recognizing the errors and fixing them. So let's see how this works. And there we go. I think it's looking good. I think this is working. So now you can see that again, we have this time value here. And this is always expecting us the time, the current time as a float value. I mean, you could also kind of do a custom input, but the easiest way is just to use the system time, grab the seconds, and you want to change this from the integer to float, because otherwise it's only sending you the full seconds. But you also want all the decimals in between, right, to have a smooth animation here. Interesting, it's not looping, or maybe that's just the time that's resetting. We're gonna keep an eye on that for sure. So here we have the animation speed, we have the cube count, we have I think it was actually using the other tunnels as a reference here. And this is why we have a very similar result. Usually you would get some wildly different results, because I tried this a couple times and every time was completely different. And this time it's actually quite coherent with the other one, which is also very interesting, because that means that once you're in a very, in a sort of look that you like, or in a kind of aesthetics that you want to stick with, then you could keep all your files in there and then create like a set of different shaders in that kind of style. And if you want the opposite, then it would be advisable to just remove all of the files that you have in your folder before, just to work from a clean slate. Okay, now one thing that I want to mention is that if you expose the inputs for Resolume, so for example here at the base cube size, you can right-click sets expose input, then you get the slider that is going to be an input in Resolume, but the values are the predefined values that are defined here. So the minimum, maximum, and the default value. And I mean, first of all, we could tell the AI, we could tell Claude to normalize them, so it's always between 0 and 1. But we could also do that here, and then also set a range that we want specifically, So for instance, here we know it's going from 0.1 to 0.8, but then I'm going to change it here from 0 to 1. And I'm going to add a map node in between, so map right here. And so it goes from 0 to 1 to 0.0 to 0.8. And now we have the same range, but here we actually have a normalized value from 0 to 1. And this also allows us to, change the minimum and maximum values right here in Wire, which is also very handy. So maybe I don't want them to go to this minimum size. So now the minimum size is 0.2. And that's really cool, and probably also very handy to just map all of the ranges of the inputs to some kind of normalized range. In this case, again, we want a texture out for the output. And then we can save this as the rotating cubes. Go into Resolume, and first also we wanted to define it as a source in the category. So we want to go to our patch, to the category, go to source. And here is also where you can change your resolution. So you can change this to 4K or whatever you want. For me right now, for the sake of the tutorial, that's good. And now if we go to the sources and to the wire source and select our rotating cubes, drag them in here, we can see that we have them playing here right now, and we have our cube size exported. It's just very exciting to be able to iterate so quickly on this, and I just think it's a very interesting way of prototyping and kind of an idea generator. And I also think that it's interesting because it's not this kind of classic AI generated video, but AI is really more part of the process here. And it's interesting in this sort of, prompting something that you would imagine and then what the AI actually interprets it as. And oftentimes it's just, varies wildly from what you expected. But that's also kind of the part of the fun, I guess, for this. So yeah, that's basically it. And I'm really curious on what you can come up with this sort of technique and workflow. And leave a like and subscribe if you enjoyed, and I'll see you in the next one.